So now let's take a look at the term neural networks and what that actually means. So we're going to take an example. Say you need to make a decision, should I go to a work colleague's party? Neural networks could be deployed to help you make that decision. So a neural network makes decisions based on weighing evidence. Inputs are yes/no questions, output is a yes/no question. So you could have three inputs such as, am I free? Will it be fun? Is it near public transit? And the outcome of those three questions gets you to a more global decision output. Unfortunately, life's a little bit more complicated and some things matter more than others. So this is sort of introducing the concept of weights and thresholds here. So in this case, am I free, if we've given that a weight of 6, and the threshold overall for making this decision is 5 or above, it really only matters if you're free, because will it be fun has a weight of 2, and is it near public transit also has a weight of 2. So basically, if you're free, no matter what, you're gonna go to the party. However, if you change the threshold to be 7, or you change some of the weights around, multiple factors would contribute into whether or not you're free. It also has to be fun or near public transit. What's really important here is that as a good product manager, you have to make sure that your data science team or your machine learning team really knows all of the data that's going to be critical for making this decision. Are these three factors the only factors to consider? Perhaps you also might want to consider, is my ex-boyfriend going to be at the party? Or is the food going to be worth it? In which case you may have a different outcome. Ensuring that these teams are working collaboratively with you and have an awareness of all the important decision-making factors and criteria is really important on what makes a good model. Models aren't good or bad, they are just reflective of the inputs and decision-making criteria that you give them. So we'll take that decision, but if you're anything like me, it's actually, you may sweat the decision a lot and weigh quite a few different factors on whether or not you want to attend your colleague's party and make a more complex decision. So each layer makes decisions based on the decisions made in the prior layer. These are called deep neural networks. It's an artificial neural network with multiple layers between the input and the output layers. Often there can be dozens or hundreds, even thousands of different layers between the input and the decision output. So let's shift gears a little bit and take an image recognition task here. One of the things that you can use a neural net for is to do character recognition. In this case, recognize the input of a handwritten 7, which in an image represents actually multiple pixels in a grayscale, and each pixel has a value of between 0 and 255. And you need to understand sort of the order and where those images are, where those pixels are in an image. So it actually has 784 different inputs here if this 7 is drawn on a 28 by 28 scale. As you can see, 784 inputs, and the inputs are each of the individual pixel values. A deep neural network takes the input from each of these pixels and makes a series of subsequent decisions so that the output of this neural network can recognize the number, it's a 7. One output neuron for each digit. The neuron with the highest value is the predicted digit. It could perhaps also have an output that it's a 1, because these may look similarly depending on how it's drawn. But what it's going to give you is the confidence that it's most likely to be. These neural networks are trained by large amounts of paired input and output values. In this case, a lot of examples of handwritten numbers categorized into which digit they are representing. You probably use this every day in reality, which is the United States mail system, which uses character recognition to route mail incredibly efficiently. There's a lot more detail here around exactly how this works. I recommend classes on Machine Learning 101 if you're interested in further diving into the details of the mathematics.